You can make the air around you feel up to 15 degrees Fahrenheit cooler without air conditioning, a powered fan, or electricity. The 3-minute setup uses wet, unglazed clay, shade, and a natural path for moving air. Place 2 or 3 soaked terracotta pots in a shallow, waterproof tray near a shaded open window or doorway. Leave space between the pots, keep the clay damp, and give warmer air another opening on the far side of the room. Dry air passes across the wet clay, water evaporates, and the outgoing air can feel noticeably cooler within minutes. That is the promise, with one major limit. This works best in hot, dry weather. It is evaporative cooling, the same process that makes wet skin feel cold in a breeze. Water inside unglazed clay moves through thousands of tiny pores and spreads across the outer surface. To become vapor, that water needs energy. It takes some of that energy from the clay and the nearby air as heat. The air cools while gaining moisture. No compressor is doing the work. The water is carrying heat away as it evaporates. More water alone does not create more cooling. A bucket may hold gallons, but only a small surface is exposed to the air. Several damp clay surfaces expose far more water to passing air, which can increase evaporation. Airflow matters just as much. Without moving air, the thin layer beside the clay quickly becomes humid and evaporation slows. A natural draft keeps bringing in drier air and carrying the cooler, moister air forward. Shade is equally important. Direct sunlight can add heat to the clay faster than evaporation removes it. The basic recipe is simple: wet surface, dry air, steady movement, and no direct sun. Get those 4 pieces right, and ordinary flower pots become a small, passive cooler. Humidity sets the hard limit because air can absorb only so much water vapor at a given temperature. Hot, dry air still has room for more moisture, so water can evaporate quickly. Hot, humid air has far less room, so the same clay may produce only a small temperature change. That is why this idea has a better chance in inland Arizona than in coastal Florida. The technical limit is called the wet bulb temperature. In plain English, it is roughly the lowest temperature evaporation can reach under the current heat and humidity. The wider the gap between the outdoor temperature and the wet bulb temperature, the more cooling is physically available. A simple clay pod will not capture that entire gap. Its performance depends on surface area, airflow, clay porosity, water temperature, and how much warm air keeps entering the room. Room size creates the next limit. A small unit can cool the air passing close to it, but it cannot instantly cool the walls, floor, furniture, and every other warm object. Those surfaces store heat and release it back into the room. Personal cooling and whole room cooling are therefore different jobs. A cooler stream reaching your chair or bed may improve comfort before the center of the room changes much on a thermometer. That is not cheating. It is using a small amount of cooling where it helps most. The best arrangement creates a route through the room, not a damp corner with nowhere for the air to go. Put the wet clay near the incoming side. Open another window, doorway, or vent on the opposite side so warmer air can escape. A higher outlet may help because warmer air tends to rise, but the openings still need enough temperature or pressure difference to create a useful draft. The pod cannot create strong airflow from nothing. It works with airflow the room already has. Cooling also improves when you reduce the heat entering the room. Close exterior blinds or reflective curtains before strong sunlight hits the windows. Vent stored heat during the cooler evening or early morning hours. Then let evaporation provide the final comfort boost. This order matters more than buying extra pots. Block new heat, release stored heat, and cool the incoming air. The title says zero cost, but that needs an honest definition. If you already own suitable clay pots, collect rainwater, and use natural airflow, the setup can use zero electrical power and almost no operating budget. New pots still cost money. Water may also cost money, and the system consumes water whenever it runs. Keep the tray clean and do not leave stagnant water sitting for long periods. Hard tap water can leave mineral deposits that slowly clog the clay's pores. A stiff brush and occasional cleaning can restore some of the exposed surface. Can the cooled air really drop by 15 degrees Fahrenheit? Under favorable hot and dry conditions, a local drop of roughly 10 to 15 degrees is physically plausible. That does not mean every room will become 15 degrees cooler. The largest drop will usually appear in the air closest to the wet surface, while the room average changes more slowly. Humidity offers a useful first check, but there is no perfect universal cutoff. Below about 40% relative humidity, evaporative cooling often has useful room to work. Between roughly 40 and 60%, the effect usually becomes smaller and more dependent on airflow and temperature. In humid conditions, added water may raise indoor humidity more than it lowers temperature. Before building a larger pod, try a simple test. Wrap a room temperature bottle in a wet cotton cloth and place it in shade where natural air can move around it. Check the bottle after about 20 minutes. If it feels clearly cooler, your conditions can support at least some evaporative cooling. If it barely changes, more clay will face the same limit. For the full 3-minute setup, place 2 or 3 unglazed terracotta pots in a stable waterproof tray. Soak them thoroughly, add a shallow layer of clean water, and leave gaps so air can reach each damp surface. Position the tray near a shaded opening where air naturally enters. Open a second route for warmer air to leave. Keep splashes away from outlets, electrical cords, untreated wood, and moisture-sensitive floors. Then, measure the result honestly. Compare the outdoor air, the cooled stream just beyond the pots, and the temperature near the center of the room. You may see a strong local drop and only a modest room-wide change. That still has value when the cooler stream reaches the place where you sit or sleep. But this is not a substitute for air conditioning during dangerous heat. It should not be trusted as the only protection for children, older adults, people with medical risks, or anyone showing signs of heat illness. Monitor the indoor temperature, drink water, and move to a reliably cooled place when conditions become unsafe. Used within its limits, the pod turns 4 ordinary resources into a working passive cooling system. Porous clay spreads the water. Dry air accepts the moisture. Natural airflow carries the cooled air forward. Shade keeps the sun from undoing the work. Together, those 4 elements create a small but useful stream of cooler air exactly where it can make the greatest difference. The pot is only the tool. Give heat a free way out.